Hi everybody, I have a treat for you. I am in one of my GIS softwares. This is ArcGIS, and what I have on the screen doesn't look all that impressive, but it is. This is laser distance and ranging data, LiDAR. It's taken from an aircraft. This particular aircraft was flying roughly 7,300 feet above the ground, not sea level. And on board that aircraft is a series of instruments, one including a laser rangefinder. And it flies over a certain area, and the laser scans the ground and records the returns of all that reflection and does a bunch of distance calculating. It is the new way of doing three-dimensional mapping. Aircraft is one platform, but there are ground-based platforms that they use, that architects use to shoot buildings and create three-dimensional models of buildings. But this is for terrain mapping. This is an area where I live. It's 5,000 feet by 5,000 feet squared. What you're looking at is return values to the laser sensor on ranges. Here on the red, these little red dots, you're seeing the tops of trees. Okay? And the laser is able to, during times of low leaf growth, to actually measure more than one return. So that laser hits the top of the tree, but can actually go through gaps in the trees and actually hit the ground as well. And those are known as additional return values. For instance, you can have 4 returns of one specific laser beam. The first would be the highest, and then as it goes and hits branches and things as it goes through the trees, increases the number of returns. And usually the last return of that beam is the actual ground. So this is LiDAR information. It is a three-dimensional map of this particular area in our county, and you'll see that here pretty soon. What is so cool about LiDAR is that you can turn off, it knows, it's programmed in to know what is first, second, third, fourth return values, and they'll take the last values and they'll make those the ground values, and then they'll break them up in different returns for height of vegetation. So like the first return would be tall trees, second return might be smaller trees, third return might be brush, could be crop, okay, depending on the kind of crop. But anyway, that's how this image is formulated. Each one of these, it doesn't look like it, but I'm going to zoom in here real quick for you. Each one of those is a dot, and that dot has a distance to the sensor, and it gives you your ground elevation. I won't talk about exactly how they do that, but there's some more calculations that go into it. But this is LiDAR information. I'm going to turn off anything that's not ground. No, I turned everything off that's ground. All right, so we're going to turn the ground on, but we're going to leave all the trees off. So this would be the last return of each laser beam return. This is the last measurement taken in that split second of time. So this gives us what the ground would look like. Now this software, I can go in and we can look at this in 3 dimensions. Now I live in a relatively flat location, so it doesn't look as dramatic as if I was in a mountain zone. Okay, but this area being a higher hill than where I actually live gives you an idea. All right, I actually live, this is my property right around in this area here. So I have a place where it dips down in my pasture, which is right here. Okay, now with this software I can increase the exaggeration for more visual sake. So you barely saw it, and this is 5 times exaggeration, but it kind of gives you the 3-dimensional look at what the ground looks like. Okay, and like I said, this is a flat. Let's go 10 times. So even 10 times, we're so flat, doesn't really look all that hilly. Okay, but this is all, each point is measured from the aircraft sensor. The location of each point is measured by a global positioning satellite. And there's another instrument on the aircraft that that measures the aircraft movement, whether it's pitching, yawing, rolling, and its altitude above the ground. And that's where all the math comes in to make all these different elevations. All right, and since I live in a relatively flat area, I'm going to go ahead and leave the exaggeration on just for visual. But what I'm going to do is I'm going to close off this 3-dimensional view, and we're going to I'm going to turn the trees back on. So I'm going to come up here and I'm going to say I want all returns. So now our trees are. Now we're going to go back to 3D view, and you're going to see something a little different. Notice the points that are measuring off of the trees. Now this is exaggerated 10 times. All right, so let's turn this back to 1 on how it really looks, and we'll zoom in a little bit here, and we'll kind of move this up a little bit where we're kind of standing on the ground. You can see the heights of the trees. Okay, like I said, this is a small area. This is only 5,000 feet by 5,000 feet square. All right, but it gives you a good representation of the topography of the ground. And there's some other tools I'll show you here pretty soon. But LiDAR is taking the industry by storm in terms of recording 3-dimensional space. All right, so let's get out of here. There's another tool, and it's the profile tool, and I'm going to click on that real quick. I'm going to make a line going across this 5,000 feet square here. Double click there, and then I want a swath. We'll make it there. And then it brings up a profile of what I just put that line through. So you can kind of see where the trees are, and this blue area down here is the ground. That is the last return from the laser beam. So the laser, the aircraft's flying over, and its lasers going back and forth like this as it's flying. And those beams will come straight down, hit the tree, and record that as the first return. Go down and see if it gets through gaps. Maybe it hits something else. That would be the second return. Third return, and then the fourth. You can have more than 4 returns, obviously, but let's pretend that only 4 returns came back. That 4th return would be when it hit the ground and the signal returned back to the aircraft. All right, so that's what I'm talking about when I'm saying returns. So LiDAR is extremely powerful, and as I move through my profile, you can see the red line up here moving through that swath of geography to let me know where that is. Okay, now let me see if I can get this right, but I'm going to make a small line going through my property like this. Double click there, and it's going to create a swath. And if you notice, here's the line. This is the ground. This really is how my yard is. We have a low spot on the west side, and on the east side, it's about the same until it gets to our pasture, and then it starts going down. But here's the cool part. These right here, these points right here, are the first return off of a tree line that we have right down this way on our property. But the scan, notice, yeah, there's a little tree right outside of our house here, okay? But see this right here? This is the pitch of my roof of my house right here. That was the first return in that area right here. And that is the shape of my roof. This is a gable roof this way, and this is a gable roof this way. Then we keep scanning over toward the east, and we hit some trees that are outside of my garage. And then you can see my garage pitch right here. Okay? And then just east of my garage, there's some more trees. And then we get out to our pasture. So it does work. It's quite impressive. Okay, what I'm going to do right now is I'm going to show you another dramatic place, and let me kind of back up and see if I can find it really quick. Let's go to LiDAR here. We're going to go to Athens County, Ohio, and I'm going to bring up this one, and we are going to zoom in to this area here, and I'm going to shut this one off, and let's see, let's go ahead and remove this one from our table of contents. All right, so this is Athens County. This is down where I teach in Hocking College. The ground is a lot more dramatic down there. This is the topography, and this is one-time zoom. I mean, this is one-to-one relationship of the ground. So it's a lot more hilly. It's down in Hocking Hills. This is part of the campus. These two right here are the first returns for a couple dorm buildings that they have right up on the side of the hill. This right here is the main student activity building and the admin building. And then right in here is the natural resources building where I teach. Okay, but if you notice that you can see the trees that are on the hill, and you can make out the line of ground that's underneath those trees. So LiDAR does an excellent job of 3D mapping. This is very, very revolutionary stuff. I mean, it's been around for a while, but it's getting more and more popular in collecting three-dimensional data. This is the first return right here. This is the first return of the top of a building. So you can use LiDAR information like to collect building footprints. Or if you already have a layer of building footprints, you can use the LiDAR information to give that building footprint a numerical value for the height of the building. And so you can show the buildings in 3D as well. So this is, my friends, LiDAR, and this is awesome stuff. Okay, so I just wanted to give you a little bit of introduction, and we'll talk about this some other time in another article. Anyway, have a great day. See you later. I got to turn it off by here.